Hi students, 4.1 day 2. Please stop the video and write out what you see. I'm going to go ahead and get started rationalizing the denominator. Say it 3 times. Rationalizing the denominator. Rationalizing the denominator. You need to get used to me saying that because when I ask you, hey students, you need to make sure you rationalize the denominator. You need to know what I'm talking about. It is the process by which a fraction is written so that the denominator contains only rational numbers. So no radicals. Remember I talked about that in day 1 video. I said you cannot, when we use the quotient property of square roots, I said there's going to be a point where you cannot have a radical in the denominator. So it's going to ask you to simplify and you can't leave your answer like this. So how do we get rid of it? We get rid of it by rationalizing the denominator. So you're asking yourself, I need to make this a perfect square. We're taking the square root of 2. So in order for me to make it a perfect square, I know that I need to multiply it by itself, right? And so whatever you do in the numerator or denominator, you must do whatever you multiply in the numerator, you must multiply in the denominator. So again, I'm trying to create a perfect square here. If you multiply it by itself, you're going to create something called, here, anytime that you're multiplying square roots and you have a whole number and a square root, you're taking this 5 and you're multiplying it by that imaginary 1. So 5 times 1 is 5. 5 root 2, and then remember, if you're multiplying the square root of 2 times the square root of 2, you're multiplying the radicand, okay, which is square root of 4. And now we know that this is a perfect square. It is 2, 5 square root 2 over 2. I can't simplify any further. I can't divide these out, okay? These are not like terms. A whole number 2 and square root of 2 are not like terms, so you can't cross that out. If this were a 6, then you can divide. 6 divided by 2 is 3, and 3 root 2 would be your answer. But we can't simplify any further, students, so we'll just leave it like that. Okay. Again, it's asking us to simplify. That means rationalize the denominator. So we're going to multiply. We're trying to create, again, our goal is to create a perfect square in the denominator. And so it's multiplying by itself. So square root x equals, remember there's that imaginary 1 there, 4 square root x over square root of x squared. We know that we have a perfect square, it's x, so final answer is 4 square root x over x. All right, let's keep going. Okay, so square root of 3n, rationalize the denominator, square root 3n, square root 3n. Remember up here, this is the whole number 5, so we have to multiply by that imaginary number. But if you have 2 square root symbols, you multiply on the inside. So we do have 2 square root symbols here, and you're just simply going to multiply what's on the inside. 5 times 3n is square root 15n. Do not forget that square root, okay, square root 15n. And then we know that this gives us 9n squared. So this is 9n squared. And we know it's a perfect square, right? That's our whole goal, is to get rid of the radical sign in the denominator. And this is 3n. Okay. All right, let's go ahead and take a look at number 51. Number 51 out of your textbook. 3, it's division happening here, and we can, again, the quotient property of square root says we can separate the two. Let's see. So a lot's going to happen here. Just stay with me. We're able to separate. And now we know, hey, let's go ahead and multiply this by square root 5, because our goal is to create a perfect square. So these are both under the radical symbol. So let's multiply. 3 times 5 is 15, and then we have 15 square root 15b squared. I'm gonna have to simplify this because this, students, is actually a perfect square. This is a perfect square. It's d. Okay, so we're gonna simplify that right now. Take that out. You're left with 15 on the inside. This is square root of 25, right? This is also a perfect square. There's your answer. Okay, so a lot was happening in number 51. Occasionally that will happen where you can simplify. You will have a perfect square in the numerator and the denominator. Okay. All right, the next thing I want to talk about is conjugates. Anytime you have something funky that looks like this, like 2 minus square root 3, or x plus square root y, or 1 plus square root 3, or 4 minus square root 5, and you're left with it and it's asking you to simplify, what you're going to do is you're going to multiply it by its conjugate, which is like the opposite. You have a positive and a negative of that. And so when you do that, watch what happens. It gives you a perfect square, or you get rid of the radical symbol. Because remember, that's your whole goal, is to get rid of the radical symbol. You can't have radicals in the denominator. So what is the conjugate? Just pay attention, and then hopefully by the end of this, you'll realize, oh, that's what the conjugate is. So we have x plus square root y. The conjugate would be x minus square root y. If they give you x minus square root y, then the conjugate of that is x plus square root y. Okay, so it works both ways. All right. 1 plus square root 3, the conjugate is 1 minus square root 3. Okay. And if you have 4 minus square root 5, the conjugate is 4 plus square root 5. So you're looking at, this is a positive, it's now a negative. This is a positive, it's now a negative. Negative, it's now a positive. Okay. So this brings us to example 5, where it's asking you to simplify, just like it did in number 4. It's asking you to simplify, but then you get this weird expression in the denominator. It's not similar to square root 2 and square root x and square root 3n and square root 5. It's 2 minus square root of 3. So when you see something like this, students, the whole idea is to multiply it by its conjugate, which is 2. So we have a negative here. We know it's good. Our conjugate is 2 plus square root 3. So if you multiply it by its conjugate, watch what happens. So anytime you have multiplication here, we know we're multiplying. But before we do that, I'm going to share with you what's going to happen here. I'm going to share it just one time with you, and then hopefully after this, it will never, I don't have to share it with you. I have a feeling in our warm-up I'm going to have to share it with you, because some of you are not watching the video. So this is what happens when you have an expression, a binomial times a binomial. Excuse me. You can use the box method, the FOIL method, the rainbow method. I'm going to use the FOIL method. It's easier to show. So I'm going to multiply these two. Okay. Remember, FOIL is first. So we're going to multiply the first term. So here are the first terms. 2 times 2 is 4. Okay. The outside terms that are on the outside. 2 times square root 3, remember you have that imaginary 1, it is plus 2 square root 3. The terms that are on the inside is minus 2 square root 3, and the last terms would be you have a negative square root 3 and then negative and a positive square root 3. Okay, multiply these numbers on the inside and you get minus square root 9. We're going to simplify right now. Okay, so you end up with 4. Take a look. The plus or minus cancels those out. And then this is a perfect square. It is 3. And so your answer is 1. Okay, so that's what's going to happen here in the denominator. But I'm going to show you a little trick. Knowing this, knowing that I just explained that to you, if you multiply it by its conjugate, remember a positive, negative, okay, that's always going to cancel out the middle term. I call this the middle term. This is the first term. This is the first, what you get out of multiplying the first terms. This is what you get multiplying the last two terms. These are the middle terms, okay? They get canceled out. So knowing that this is true every time that you multiply it by its conjugate, then all I'm going to ask you to do, students, is just multiply the first and the last terms, because we already know, I just shared it with you. We already know that the middle term is going to cancel out. So we can multiply 2 times 2 is 4, and then negative square root 3 times a positive square root 3 is going to give you a negative square root 9. And then you can just go 4 minus 3 gives you 1. So it kind of cuts down. This is all the work you need to show. It cuts down all of this multiplying. Okay, you can just multiply the first two terms and the last two terms, simplify, and then add or subtract. Okay? All right, so again, if you need to stop the video, write that down, put a star next to it. I'm going to show you. I'm not going to show you the FOIL method every time. I'm just going to show you, because we're multiplying by its conjugate, multiply the first terms and the last terms, and then simplify. Okay. Another thing I want to talk about is there was something else I wanted to talk about. I can't remember. Okay, so I'm not going to waste our time. Let me see. I can't remember. Okay, so let's go ahead and write that down. I apologize. It's kind of blanked out. So we have 7 times 2 plus square root 3. And then again, we said this is 4. Multiply these two, you end up with negative square root 9. And then 7 times 2 plus square root 3 over 4 minus, remember this is a perfect square, 4 minus 3, which is 1. So your final answer is 7 times 2 plus square root 3. You can multiply these. 7 times 2 is 14, and then you end up with 7 square root 3. So 14 plus 7 square root 3 using the distributive property. Okay. So any one of these will work. I think I want you to, simplify, so this one. Okay. All right. Let's take a look at one more, and then we'll call it a day. This is number 58 out of your textbook. Okay, so again, it's going to ask you to simplify. So we have this expression in the denominator. I'm going to multiply it by its conjugate because that's what we just learned. So it's going to be 6 minus square root 5. 6 minus square root 5. Okay, what's happening here? Remember, if you're going to take this, Actually, we can just, let me show you. I'm multiplying 6 minus square root 5 over, now remember, we can multiply the first terms, which is 36, and multiply the second terms, which is negative square root 25. We know this creates a perfect square, it's 5. This square root 5, we're going to multiply here and here, but remember, you're not multiplying these two numbers, you're multiplying, because this is a whole number, you're going to multiply it by 6 times 1 is 6 square root 5, and then you have square root 5 times square root 5 minus square root of 25. So we're going to simplify there as well. All over. Remember we said, so there's a lot happening here. This is square root of 25 is 5, so 36 minus 5. Again, I'm showing you step by step. I'm going to simplify this at the bottom, and I'm going to simplify that. So it looks like final answer is going to be 6 square root 5 minus 5 over 31. And you cannot simplify any further. Okay, so a lot was happening there. And again, that's number 58. We're multiplying conjugates.